do a normality problem. And this problem says, what is the normality of a solution of 23.8 grams of sulfuric acid in 1.25 liters of solution? And I'm going to show you how to do this problem two different ways. You may remember that we can find normality by taking equivalents per liter of solution. We can also do it by finding the molarity and using the molarity. So let's do it that way first. So we're going to change the grams to moles to find the molarity. So 23.8 grams of sulfuric acid. If I'm changing grams to moles, then that's 1 mole of sulfuric acid. And I previously added up the molar mass of sulfuric acid, 2 hydrogens, a sulfur, and 4 oxygens. That is 98.1 grams of sulfuric acid. So the grams of sulfuric acid cancel out, and that gives us 0.243 moles of sulfuric acid. If I'm going to find the molarity, I just divide that by the volume. It's already in liters for us, so that's nice. Gives us 1.25 liters on the bottom. Doing this division, then we come up with a molarity of 0.194 molarity. Now, to find the normality, knowing the molarity, it's simply a matter of looking at the original compound and counting how many hydrogens, and look at it up there. There are 2 hydrogens. And so we just take the molarity and multiply it by 2 hydrogens. And so when we take 0.194 times 2, we get a normality of 0.388. That point's not showing up. And the unit on that is a capital N. So here is our answer, 0.388 normality. That is the molarity way of doing the problem. Now there is another way to do the problem using more straight molarity, or normality type units. So we can start with the same thing, 23.8 grams of H2SO4. But now we're going to do something different at this point. We're going to change it not to moles, but to equivalents. And so one equivalent is equal to the molar mass divided by the number of hydrogens. So again, it's still 98.1 grams for the molar mass, but now we just take that and divide that by the 2 hydrogens. Okay, so it ends up being 23.8 grams of H2SO4 times 1 equivalent over 98.1 grams. So the grams of this will cancel out the grams of that. And this time, instead of 0.243, my calculator tells me it's 0.485, and that's equivalence of H2SO4. So then we just take that number, the number of equivalents, and divide it by the volume, which is 1.25 liters. So when you do that division, you're going to find that you get exactly the same answer. And that's capital N, equivalents per liter. So it doesn't make any difference which way you do this problem. You're going to get the same answer. So you just have to decide for yourself whether you would prefer to do it as a molarity problem and then change it, or whether you'd rather do it as an equivalence problem and end up with the answer in the end.